this manner. So if I look at this counter, this output Q0, what I find? 0 to 1, 1 to 0, 0 to 1, 1 to 0. So always it is toggling. A simple observation. Q0 always toggles. In a 2-bit counter, the least significant bit Q0 always toggles. So what is the simple way with which I can make it? I will keep this J and K at 1. So not this is Q0. J and K at 1, 1. So this input, this I will call 1 and 1. So this is J, input J0, K0 I can say. Input J0 is 1, K0 is 1. So Q0 will always toggle. Q0 will always toggle. What about Q1? What about Q1? Q1 is 0, it continues 0. It changes to 1. It continues 1. It changes to 0. And this will always be there. So there is a very interesting thing of observation of Q1. Observation of Q1 is that if when it continues, you can watch this continuation, you can observe. And this inversion you can observe. When continues, when inverts. When continues, when inverts. So we find that it's a very important observation. When Q0 is 0, that time it continues to have the state. When Q0 is 0, means if Q0 is 0, in the next cycle Q1 continues. Q0 is 0, next cycle Q1 continues 1. And when Q0 is 1, Q1 toggles. When Q0 is 1, Q1 toggles. So it's very simple. Those who want to think on their own should put a pause now, think and then watch. And those who want to watch, they can continue watching. That is obviously for those who are watching neatly. Those who are not watching and just put the YouTube on, for them there is no question. This discussion is futile. So if Q0 is 0, in that case the next state of Q1 is continuation. And if Q0 is 1, next state of Q1 is toggling. So inputs of this flip-flop J and K either should be 0, 0 or 1, 1. They should be either 0, 0 or 1, 1. If they are 0, 0, it continues. If they are 0, 1, it toggles. So if they are 1, 1, it toggles. So inputs J and K should be 0, 0 if I want to continue. Input JK should be 1, 1 if I want to toggle. When I want to continue, when Q0 is 0, I want to continue. When Q0 is 1, I want to toggle. So I can directly connect Q0 to this J and K. So if I connect this to J and K, what will happen? So here, these are 1, 1. So right now, this is 0, 0, let us say. Both are 0, 0 initially. So when both are 0, 0 initially, this is 1, this is 1. And as it was 0, 0, this is 0 and this is 0. So clock is applied to both. Clock is applied to both. So this is 1, 1. So this 0 becomes 1. But this is 0, 0. So this 0 continues 0. This 0 becomes 1. This 0 continues 0. Now this is 1. Now I have come here. So at this time, this is become 1. So this is also 1, 1. So then when this is 1, 1, clock comes. Clock comes here. This toggles from 1 to 0. And this is also 1. So this toggles from 0 to 1. So in this way, we continue the simple counting. So in the next lecture, we will go for multiple bit counter, then a down counter and a random number counter, say not random number, it is 2-bit counter, 3-bit counter. So 2-bit counter 4 states, 3-bit counter 8 states. But suppose if I want some counter to count only up to 5 and then 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and then it should come 0, 0, 0. So mod 6 counter that we can go for. And I think in the next lecture we will be able to finish the counter and also shift register. So I think that would be, in fact actually as we are moving with more details, we are somewhat slow, but I am sure that we will be able to cover everything in time. Thank you.